All right, hello. So in this lesson, we are going to take what we've already talked about for identifying transformations, including those for our new parameter 1 over b, and apply them to creating a graph of the transformations for a particular function. So here, this just kind of summarizes much of our new stuff. So our negative 2/5 based on its position inside the parentheses and times the x minus h portion, this would be our 1 over b, shown here. And then we don't want to use that, remember. We want to use b, which would be its reciprocal. So negative 2 over 5 becomes 5 over negative 2, or negative 5/2. Now it is negative, meaning it's less than 0. So we do have a reflection. And remember that with our b, that reflection is a y-axis reflection. Then we look at the absolute value of b, which would be positive 5/2. And this is, remember, an improper fraction because the numerator of 5 is larger than the denominator of 2, and all improper fractions are larger than 1, which means we have a stretch because our factor is larger than 1, and the type of stretch we get with b is our new horizontal stretch. Then for h, we have to remember to take the opposite of what's inside the parentheses after the x to get the correct h. So we're taking the opposite of that minus or negative 3 to be positive 3, which means that we have a translation to the right 3 units. And then what we find at the end outside of the parentheses is by definition k, and we don't change that one. So k is negative. So k tells us here that we're going to go down that negative direction for k 5 units. So this, which is in your notes, can be a little overwhelming looking at first, but we're going to break it up. And I would encourage you to either break it up with highlighters or with sort of like just grouping things together with braces or something like that. So here, these first 3 are all talking about what we conclude from our a parameter. So if we have a, all 3 of these, they're all about a. So either, I would say, highlight them in your notes or bracket them together. The next 3 we can see are all about our b, which comes from the reciprocal of our new parameter 1 over b. So all 3 of these are all about what we conclude from our parameter b. They're all together. Then we see, okay, the next 2 are reminding us what we conclude based on our h value. So these 2 come from h. And remember, to get the correct h, we have to take the opposite of that. So h is negative if we have a plus, and h is positive if we have a minus, like shown here. And then the final 2 we can see are about what we conclude based on k, which we find at the end outside of our parentheses. So we've got those 2 for h and those 2 for k. So it just sort of visually helps you break it down when you either bracket them, group them, or highlight them in different colors to help differentiate between the parts. Now it's more usable, user-friendly to do that with it. All right, so now this is just kind of a written procedure for what we're going to do to apply our knowledge of transformations to creating a graph. So we're going to be given a graph at this point that is going to be just a general graph of points. But we're going to want to identify the key points that we can identify, which would include endpoints, maximum points, which remember are like peaks, minimum points, which would be a point at the bottom or a low point, and intercepts. Intercepts means like your x-intercept and your y-intercept. Those would be key points that you would want to identify the coordinates for and then transform them. So these points are the points that we're going to transform. We also want to identify, of course, the transformations that are going to take place. That's what we were doing yesterday. And you can do actually step 2 first and then step 1. These two are interchangeable. All right, so you can switch these around if you want to. Doesn't really matter. Then once you know your points and you know what your transformations are, you're going to start doing those transformations. Now, you need to do reflections, stretches, and compressions first. So these are first. And you want to do all of your translations last. Do the translations last. Between reflection, stretches, and compression, you can do the reflection first or the stretch first. You can do the reflection first or the compression first. That doesn't really matter. And sometimes I choose to do one first and sometimes I choose to do the other one first. It just depends on whatever I think would be easiest for that particular graph based on what I'm thinking. And then we will connect our transformed points to create a sketch of our curve or graph for the new function. All right, so let me show you what that's all going to do here. So one of the things that we have to do is identify those key points. So the first thing I'm going to do is my key points, just following the procedure from the previous slide. So I do endpoints. I would do intercepts, like the y-intercept here. I would do this minimum, which is also an x-intercept. Okay, so I want to know what are their coordinates. So I'm looking at, okay, those are the ones that I want to transform. Actually, I guess I don't really need their coordinates, quite honestly, the way we're going to do it. Sometimes it can be helpful to write them down, but we're not going to do a whole bunch of math. We're going to visualize stuff today, so we really don't need their coordinates. So we'll just leave that part off. All right, second, we're going to figure out what our transformations are. So our 1/3, which is inside our parentheses and times our x minus h part, that's our 1 over b. It is positive, so there's no y-axis reflection. It's reciprocal, so we've got b would be 3 over 1, which is just 3. And 3 is greater than 1, so, well, absolute value of 3. And so that gives us a stretch. And because we're dealing with b, we're looking at it being a horizontal stretch. And the factor is 3. So I'm going to write that down. So I have a horizontal stretch. And my factor is 3. What this means for my horizontal stretch is that I'm going to take all of the horizontal distances from my y-axis, which is right here, and I'm going to multiply by 3 and make them 3 times bigger. That's what that means. Then after I do that, this plus 2, that's in the h position, so I have to take the opposite of that to get my correct h, and the opposite of the plus or positive 2 would be a negative 2. So this is telling me I have a translation to the left 2 units. So after I make all of those horizontal distances to the y-axis 3 times bigger, then I'm going to count 2 units to the left. And here's where it can get a little tricky. We're going to have to pay attention to our scale. So notice here, our scale, all those main lines are 2 units. So if we're counting units, it means by ones. So when we count 2 units, we count by ones. We have to pay attention to our scale to make sure we're counting by ones. All right, here we go. This first point. All right, so I'm taking, for this point right here, I'm looking at this horizontal distance to my y-axis, which is 2 units, because I'm 1, 2. You can also look at it as sort of like 4 little squares, I guess, but it's 2 units. So I'm taking that 2 units on the left side, and I'm multiplying it by 3. So 2 times 3 is 6. So that's telling me I'm now going to be 6 units on the left side. So here's my 2. This would be 3, 4, 5, 6. So now it's here. Then I'm going to count another 2 units to the left from here. So I have 1, 2. And this is where my final point ends up. So this distance stretches. Now it's 3 times further away, and then it moves 2 units further to the left and ends up there. For this point, it's on the y-axis, so its distance is 0. And anything times 0 is still 0, so the stretch doesn't affect it. But it still does move 2 units to the left, like counting 2 units. 1, 2, and ends up right there. So now these two are connected. This point down here, it's 1 unit to the right of the y-axis. So that 1 unit gets multiplied by 3. So it's now going to be 3 times bigger, 3 times further away. So this is 1, 2, 3. So now it's 3 times the distance. And then it moves 2 more units, but it does it back in the left direction. 1, 2. And it actually ends up right back where it started. That doesn't happen very often, but this one did. And then we have this point. So it is 2 units to the right of the y-axis. So that horizontal distance of 2 units stretches to 3 times its length. 2 times 3 is 6. So here's 2, here's 4, here's 6. So now it's 6 units to the right. And then it's going to move back 2 units to the left. 1, 2, and end up right there. And then I can connect those. And then really I would get rid of all this stuff that I've used to kind of show you what's happening. So all this is just gone. And there is my new function g of x, like so, in orange. All right, so let's look at this second example. So the key points that we would transform here in this problem would again be our endpoints. This minimum point, which is at the bottom, if you remember from your parabolas, like the point at the bottom of a parabola, and then our y-intercept. All right, let's identify the transformation. So -2, once again, is inside the parentheses times the x minus h part, so that's our 1 over b. And -2 is an integer, so we know that it has a denominator of 1. So when we do its reciprocal for b, we get 1 over -2, or -1/2. So since it's negative, this time we do have a reflection, and we have to remember the type of reflection is a y-axis reflection. You also have that chart in your notes as a reference for if you're not sure. If you think if you're not sure remembering correctly. So this will give us a y-axis reflection. That means top, bottom, or up, down. If that's not something you were already aware of. Okay, wait. That's not right. Y-axis means, here's our y-axis. So that means left, right. My apologies. So this is left and right of the y-axis. There we go. X-axis is where we go top to bottom, up and down. All right, then we want to look at the absolute value of b. The absolute value of -1/2 is +1/2. Compared to 1, it's smaller than 1. It's a proper fraction. So we have a compression. The type of compression with b, we have to remember, is a horizontal compression. And that means, again, left, right. Then we have this parameter here. That's going to be our h if we take the opposite of it. So our h would be positive 1. So we're going to go to the right, that 1 unit. And then here, what we find out at the end outside of the parentheses is our k. So k is also 1, and that'll take us up 1 unit. All right, so I like to start with one of the endpoints and work my way either to the right or the left. So I'm going to start with this endpoint. So I must do my compression and my reflection before I do my translations. Now it's my choice whether I want to do the compression or the reflection first. Okay? In this case, I want to do my compression first, and then I'll do my reflection. So I am looking at this horizontal distance, which is 4 units, and I'm compressing it by my factor of 1/2. So it's like dividing it by 2. 4 divided by 2 is 2, so it compresses to right here. Then it flips across the y-axis from the left side to the right side. So it flips over here, 2 units on the right instead of the left. Then it does its translations. I have 2 translations. Does not matter which translation I do first. So I can go right first or up first. Because notice if I go up then right, if I go right then up, they end up in the same position. So this is the final position of that leftmost point. All right, so now I'm going to move on to this point down here. So what I'm looking at here is compressing this horizontal distance of 2 units by a factor of 1/2. So it's like cutting it in half, dividing it by 2. And 2 divided by 2 is 1. So it splits the difference, and it's right there. Then I'm going to reflect it. So now it flips across from the left side of the y-axis to the right side of the y-axis. And then it moves according to the translations. Right 1, up 1, and it ends up right here. So I have this. Now remember, this is a curve. And that's the bottom of my curve. So I want to make sure that I graph that as a curve. Moving to my third point, which is right here. It's on the y-axis. So it's like a horizontal distance of 0. And so the compression doesn't change that. The reflection, since it's on the y-axis, not on the left and not on the right, it stays exactly where it is for the reflection too. But it does still translate, right 1 and up 1. So now it's here. So that completes the U part. This part right here is now right here. Then we have our fourth point. So it does have a horizontal distance of 1 unit on the right side. So that's going to get cut in half. So 1 divided by 2 is 1/2. So it's like right there in the middle. And then it's going to flip from the right side of the y-axis to the left side. That's the reflection. And then it's going to move 1 unit right. So since I'm in the middle, I have to remember for 1 unit, I have to move back to the middle here and then up to the middle there. And then this gets connected to that point right there. And that then gives us our g of x, which is now in green. All right, we're now looking at this third example. So this one's a little different. This happens once in a while that we don't see those nice dots for points like we have in the previous graphs. So we'll just create them ourselves at the key locations. The key locations would be the endpoints, would be this maximum, which is also the y-intercept, this minimum, and then I'm going to add another point because see how this kind of changes direction, kind of like curves through that. We call that an inflection. And so we're going to add this point. All right. So now let's identify our transformations here. So this -2 is in front of our parentheses. That makes it our A. So because it's negative, we do have a reflection. But the type of reflection we have to remember with A is x-axis. So this gives us an x-axis reflection. We do not do the reciprocal because we've got A already. We only do the reciprocal when we have that 1 over B. So we end up with B. So here now we do the absolute value of A, and the absolute value of negative 2 is 2, which is greater than 1. So that gives us a stretch, and with A, like we've known before, that is a vertical stretch. And our factor of that stretch, remember, is our absolute value. So we have that factor of 2, which means that we're going to take the up-down and multiply them by 2. So vertical distances go to the x-axis. They're up-down, and we take them and multiply them by 2 for our stretch. And the x-axis reflection is an up-down reflection. So what's above moves below, and what's below moves above. So that takes some practice to keep straight for some people. Then we have this minus 1. In that position, the opposite of that would be our h. So that is going to give us an h of positive 1, which means that we're going to go to the right 1 unit. And the plus 6, which is at the end after the parentheses, would be our k. K being a positive 6 means that we're going to go up 6 units. So we have to remember do these first, and we have to do these last. All right, so let's start with a point. So let's start with this point here. This is where don't go too fast when you're doing these problems on your own, and double check what you've written down. This is a vertical stretch, so I want to focus on my vertical distance, which is right here. So that's 1 unit vertically to the x-axis. That is being multiplied by my factor of 2, so it's stretching to 2 units, which is here. Then it's going to reflect across the x-axis, which is up to down. So it's going to move from above at positive 2 to below at negative 2, which is a little bit off of my graph, but that's okay, because I'm going to move up 6 units and write 1 unit. So I'm coming back up 6, 1, 2, 3, 4, 5, 6, moving right 1, and it's going to end up right there in its final location. All right, next point. This is where we got to be careful. Remember, we're doing a vertical stretch. So we're looking at this vertical distance to the x-axis, which here is 3 units. That vertical distance is going to stretch by a factor of 2. So it's like taking the 3 times 2, which moves us to the 6 way up here. Then it's going to reflect. So it moves from this positive 6 up here above the x-axis all the way down here somewhere to negative 6. So here we kind of have to do some mental math. So we're going to take that negative 6 and we're going to come up 6 units. So it's like taking negative 6 plus 6, which is 0. And then it moves right 1 unit, which puts it right here for its final location. So notice this is arcing. So this is going to arc like so. All right, so let's do this one. So this one, we're going to take this vertical distance, which is 1 unit. That 1 right there tells me this is 1 unit. We're going to stretch it to 2, because 1 times 2 is 2. We're going to reflect it down here to that negative 2. We're going to move it up 6. 1, 2, 3, 4, 5, 6, and write 1. And that then creates or finishes this little arch we have, which now actually is down. All right, next point. I'm going to change colors for clarity here. This one. Now this right here, that's actually only a half a unit. So sometimes you might use the smaller squares to help you. So we're going to take a half times 2, which is 1, or you're taking 2 small squares times 2, which makes it 4 small squares. Either way, it puts it right there. Then it's going to reflect, so it's reflecting from 1 above to 1 below. Then it's going to go up 6. 1, 2, 3, 4, 5, 6, and write 1. Puts it, I think, right around in there. We get that piece right there. And then our final point, it stretches to 2, reflects down to that -2, moves up 6, moves over 1, and ends up, whoops, moves up 6 and moves right 1 and ends up right there. And there's our g of x. All right, so like I said, the basics are there. It just takes practice to get comfortable with moving all these points around. And that'll finish up this lesson.